Okay, so today is going to be a calculator lesson. All of the front page are the directions for the calculator problems. So this first one, we're going to input this table into your statistics part of your calculator. So first thing you're going to do is you're going to go and turn your diagnostics on. So we're going to hit second and catalog, which is down here above the 0. I'm going to try to let you see both the words and the calculator. So I'm going to hit 0 over here. Okay, and now from here, I need to scroll down until I see the phrase diagnostics on. So it's obviously in alphabetical order, so just find that one. All right, make sure you choose the one that says on, hit enter, and then make sure it says done. So you may have to hit enter twice. All right, so all I'm doing is following the directions. So I'm going to enter the data. I'm going to go to stat. So find your button that says stat, which is right here. And number 1 is edit. So I'm going to hit enter. And then I have some numbers in here, so since I do, I'm going to hit up and clear and down. Don't hit delete, make sure you hit clear. So I have L1 and L2, but if for some reason you don't have L1 and L2, I want you to go to stat and number 5, which is setup editor, and then that'll give you L1, L2, L3, and so on. So make sure you have L1. We're going to put all the x coordinates in for L1. So we got -5, -2, -1, +1, 3, and 6. And then for y, we're going to put those in L2. So that's 22, 15, 12, 8, 7, and 5. So please double check that you have the right numbers in the x column and the y column. All right, so now if you get it lost, you can always go through and read all the directions here. So make sure you have all the right numbers. So now we're going to find the equation. We're going to go to stat and hit the right arrow, and number 4 is linear regression. Okay, so you just have to hit enter a whole bunch of times. So I'm going to hit enter, and this gives me my equation. So when you see that, the a is it's like ax plus b instead of mx plus b, so this is your slope. So notice here it says -1.54 that we just rounded to 2 decimal places, and then the y-intercept is 12.01. So again, we just rounded to 2 decimal places. All right, the correlation coefficient is the r, not the r squared, so you just copy that number down. If it's close to -1 or +1, that tells me that my points are very, very close to the line that is the linear regression equation. Okay, so we're going to go through and do 2 problems on the back, so you'll still need your calculator. All right, but first we're going to draw the graph on paper. So it says make a scatter plot of the data. So the first row is going to be my x. So I'm going to write experience here in years, and the hourly rate is my y, and those are in dollars. All right, so I need to make sure I can go from 1 through 12. So sometimes we need to count by something other than 1, but for this problem we should be able to get everything in by counting by 1s. All right, for here we need to go up to 20, so I'm going to count by 1s, but I'm only going to write down every 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, and if we need a title, this is the hourly rate of pay for each technician. So I guess we'll call this experience versus hourly rate. Okay, so now I'm going to put my points on. So 9, 17, 4, 10, 3, 10, 1, 7, 10, 19, 6, 12, 12, 20, and 8, 15. All right, so notice we're not going to connect the dots because it would be like a zigzag line. So we're just going to draw a line that pretty much represents the trend of the line, trend of the points showing upward. So as my experience increases, my pay also increases. So basically this is what your calculator is going to do for you. So it says find the correlation coefficient and the line of best fit. So this is all on your calculator. Okay, so if you need to go back and follow the directions on the other page, go ahead and do that. So to do this problem, we're just going to hit stat and edit. Notice these are the numbers from the previous problem, so we're going to hit the up arrow and hit clear and down. And I'm going to type in my new x coordinates. Okay, and I'm going to go over to L2, go to where it says L2, hit clear, and then down, and then you can put in your new y coordinates. Okay, so now I've got my x's and y's. You could double check that you have the right numbers in. And then I'm going to hit stat, move over to the right, and then do linear regression, which is number 4. I guess I hit enter 5 times, and then here's my answers. So I'm going to take my correlation coefficient. This is my R. So R equals 0.989. I have to round to 3 decimal places. So that's my correlation coefficient. My line of best fit is my y equals mx plus b. But notice your calculator does ax plus b. So we're going to do 1.23x plus 5.57. All right, there's my line of best fit. And then you need to use this equation to predict the hourly rate of a technician with 18 years of experience. So since experience is x, this number is going to go in for x. So I'm going to write y equals 1.23 times 18 plus 5.57. And then that's just something you could plug into your calculator. So we're going to do 1.23 times 18 plus 5.57. And this tells me that a technician with 18 years of experience should be making $27.71 per hour. All right, problem number 2. It's comparing the, it says in most cases temperature decreases with increasing altitude. So this is my x, this is my y, so my altitude is in feet, and my temperature is in degrees Fahrenheit. All right, so this time I don't want to count by ones because I have to go to 10,000. So I'm going to count by, I need to get up to at least 10,000. So we'll say we need to get to 11,000. So if we start counting, here, we'll go backwards. This will be 10,000. This will be 9,000, 8,000, 7,000, 6,000, 5,000, and 4,000. Perfect. And it's okay that we didn't start at 0. So there's a little break there. All right, so now for temperature, I need to get up to 61, but my lowest is 46. So if I start at like 45, 1, 2, 3, 4, 5, this will be 50, 55, 60, and that's as far as I need to go. Perfect. All right, so now I'm going to plot. We've got 7,561 degrees, 8,258 degrees, 8,656 degrees, 9,250 degrees, and 10,446 degrees. All right, so notice these are going downward, so this would be like a negative correlation. Right? The other graph that we did was a positive correlation. So we've got, now we just need to type these into our calculator. All right, so I'm going to move this over, go back to stat, hit edit, and I'm going to clear. So make sure you always hit clear, not delete, and then the down arrow, and that gets rid of all the numbers that are already there. Okay, and then I'm going to enter in all my y values. All right, so now I just hit stat and calculate, and number 4, hit enter 5 times, and I get y equals negative 0.005x plus 100.50. I'm going to do negative 0.0052 just to make it more accurate because these zeros are not going to be very helpful. So I'm going to call this negative 0.0052x, and then my r is negative 0.998 when I round to 3 decimal places. All right, so it says use your equation to predict a temperature at a height of 12,000 feet. So since 12,000 feet is my x, I'm going to put in that number in for x. So I'm going to have y equals negative 0.0052 times 12,000 plus 100.50. And then I'm just going to use my calculator to do that. So negative 0.0052 times 12,000 plus 100.50. All right, so that tells me that the temperature at 12,000 feet of altitude is going to be 38.1 degrees Fahrenheit. Okay, and then you're all done.